The next question is a question from the 2014 AP exam. And it says, consider the differential equation dy by dx is equal to 1 minus 2 over x squared, all in brackets, times y minus 1. And again, notice that the x's and y's can be separated by times and divide, so we can separate and integrate this expression, where x is not equal to 0 because we can't divide by 0. The question also says, let y equals f of x be the particular solution with the initial condition f of 1 equals 2. That means that that point has a coordinate at x equals 1, y equals 2. Part A says, find the slope of the line tangent to the graph at 1, 2. So we need to find the slope, so we're going to use the derivative. So we have the derivative dy by dx. And we're going to plug in the coordinate 1, 2. Okay, so at x equals 1, y equals 2, we're going to calculate the slope value. So this becomes 1 minus 2 over 1 squared times the y coordinate is 2, so plug that in, 2 minus 1. Okay, so that's going to give us the slope value. So when I plug this all in, I get 1 minus 2, that's negative 1. 2 minus 1 is positive 1, so the slope value is equal to negative 1. Okay, so that is the slope of that tangent line, and using that slope, we can come up with a tangent line equation for that. Part B says, sketch the slope field at the 9 points indicated. So our slope field, we're going to sketch, and we're going to do that by plugging in x and y coordinates into our dy by dx equation. So we're just going to estimate the slopes here, but I'm going to start with y equals 1. So when I plug in y equals 1, I'm going to end up with 0 for a factor here. So when I plug in y equals 1, we get 0 factor, which gives us 0 slope. So at all the y equals 1 points, okay, we're going to end up with horizontal tangent lines through all those coordinates. Okay, so the slope field that I draw through y equals 1 is all going to be horizontal. Notice that we have no x equals 0 coordinates because that would be dividing by 0. I'm going to then go to y equals 2. So at y equals 2, we know that y minus 1 is going to be equal to 1. So we just need to consider the x coordinates. So at x equals negative 1, we get 1 minus 2 over negative 1 squared. Well, that's going to be 1 minus 2. So that's going to give us a slope of negative 1. So I'm going to have a slope of negative 1 through that point. At x equals 1, we're going to get the same. So y equals 2 again. The y minus 1 is equal to 1. So I'm going to put x equals 1. So 1 minus 2 over 1 is negative 1. Times 1 is going to give us negative 1, so we get another slope of negative 1 through there. And at x equals 2, we're going to end up with 1 minus 2 over 2 squared, which is 4. So 1 minus 1/2, that gives me a slope of positive 1/2. Okay, so that's going to give me a positive 1/2 slope, so I'm going to draw it in kind of like that. Okay, so going to x's y is equal to negative 1, that's going to give me the y minus 1 becomes negative 2. So whatever I get in the left bracket, I'm going to multiply by negative 2. So at x equals negative 1, I end up with negative 1 slope times negative 2, which is going to give me a positive 2 slope through there. At x equals 1, we get a 1 minus 2 over x squared. It's going to give me negative 1 again. Multiplying that by negative 2, I get positive 2, so I get a positive 2 slope through there. And when I work out the value for x is 2, is 1 minus 1/2. So positive 1/2 times negative 2 gives me a slope of negative 1. Okay, so there's my slope segment through there. So all I need to do is use those coordinates for the dots, plug them into my derivative, and work out the slope values and then sketch in that slope value. So that's part B. The last part of this is solve the particular differential equation with the initial condition f of 1 equals 2. So that means I need to solve that differential equation. So I'm going to separate that differential equation and integrate it. So I'm going to start with my original differential equation, dy over dx is equal to 1 minus 2 over x squared, okay, and then times y minus 1. The x's go with the dx's, the y's go with the dy's. So when I separate this out, I'm going to put the dy on the left side, and that's y minus 1. Okay, so that's going to be a 1 over y function, so I'm going to use log to anti-differentiate that part. I end up with 1 minus 2 over x squared dx. Okay, so that's just going to be power rule. I'm going to, let me just change that to blue. Okay, so I'm going to then use my integral. I'm going to integrate both sides. So on the left-hand side, I'm going to anti-differentiate this using log, so y minus 1. On the right-hand side, the antiderivative of 1 is x minus, okay, this x squared is a power, so it's going to be negative 2. I'm going to add 1, that becomes negative 1. So I'm going to end up with 2x to the negative 1. And I got to remember to divide by that negative 1, so it becomes positive. And then plus c. So I'm just going to rewrite that so that I can work with that a little bit easier. So this is going to be plus, and then 2 over x plus c. Okay, so solving for c here. I'm going to solve for c by plugging into my initial points 1 and 2. So 1 and 2 get plugged in, and I'm going to solve for my plus c. So log y is 1, so y is 2 minus 1 equals x is 1 plus 2 over 1, and then plus c. So the only thing left to solve for is the plus c. 2 minus 1 is 1. The log of 1 is 0 on the left-hand side. 1 plus 2 is 3. Solving for c, it works out to be negative 3. So c is equal to negative 3. I can write that equation now as log y minus 1 equals x plus 2 over x, and then the c works out to be minus 3. Okay, so I can then input this, I can rewrite this getting rid of the log. I can get rid of that log with an e. So y minus 1 is equal to base e, and the exponent is x plus 2 over x minus 3. And then rewriting this, this becomes y equals e x plus 2 over x minus 3, and then plus 1. Okay, so that would be the solution of f of x. So f of x is the y of that differential equation, and we end up with, in this case, I'm just going to rewrite this maybe, because now this is good enough, but that minus 3 can also show up as a coefficient. And when I rewrite that as coefficient, that becomes e to the negative 3. Okay, so I'm going to rewrite that as e to the negative 3, or 1 over e cubed. as the coefficient on there, and then times e to the x plus 2 over x, and then the plus 1. That was that from that y minus 1, and there's the solution that passes through that point, 1, 2.